Does someone came? 1 or 2 members? Nothing. Sunny Singh came. Only 2 members. Okay. Guys, here last class we discussed about a OSI model, open system interconnect. So it is a reference model. It contains 7 layers. To understand or to create a new network or to troubleshoot the network related issues, we use this OSI layer. Okay, so there's a lot of standards are there, so we don't go with now presently. I'm talking about only OSI model. 7 layers already we discussed that one. Just we are telling this. 7 layers: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and a physical layer. If you read from bottom to top, no problem. Physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Both are correct, guys. Either top to bottom or bottom to top, both are correct. But make sure you have to speak in the order. So how to do that one? Practice only. Practice. Okay. Next one, guys. So when we use top to bottom, when you use a bottom to top kind of stuff, when you are sending a packet to the destination, you are a source machine and there is a destination machine. While you are sending, that is a 7 to 1 application, presentation, session, transport, network and data link layer and physical layer. At a destination, so destination side, what it will do, it receiving a packet. So when it is receiving a packet, the packet is received to physical layer, then data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Okay, that is the thing. The bottom 3 layers are hardware layers. We are already know hub is belongs to physical layer, switches belongs to data link layer because it understand MAC address. Router is belongs to network layer because it is understand IP address, logical addressing, and routing information also. Transport is a end-to-end connectivity. It is a heart of OSI layer, and top 3 layers is a top layers or upper layers, also called as a software layers kind of stuff. The next point is we have to discuss one by one layer. So before that one, just already we discussed yesterday last class, that is protocols are about protocols and their port numbers. Protocols are used to understand what type of communication it is, what is the client request, what is the server type, what is the application you are using, that involves these points. Okay, I have a web browser. I use a HTTPS for a web access purpose. So I'm a web browser means web client side application it is. Web browser is a client, web client. There is a web server. So you want to send a request from web browser to web server, will send through a protocol. Then only will understand you are asking a web page. Okay. And already we discussed what is the difference between HTTP and HTTPS. Okay. HTTPS is our SSL. So you are accessing a web data means either you are sending or receiving a data. The data is not encrypted, so then it is not secure one. Data is not encrypted in a HTTP protocol. In HTTPS protocol, so data is encrypted using a SSL or a TLS protocols. Okay, so data is encrypted, so data is secure. HTTPS compulsory used for bank accounts, mailing communication, social media kind of stuff. We use HTTPS. Nowadays, max to max, or even a small website also people are using HTTP. Yes. Okay. FTP protocol, file transfer protocol for upload and download of files. SSH protocol used to connect a remote server for either accessing remote machine using SSH protocol, which is also do encryption. Data is transmitting. Okay, data is encrypted while it is transmitting and receiving. Telnet is also same as a SSH for connecting remote machine using CLI, command line interface type only, but no encryption. RDP, of course, there is an encryption, but RDP is to access directly a remote desktop, means a desktop environment. Directly a desktop environment like this, people can able to access, not just a command line type. Okay. Next is these three protocols are mail communication purpose, SMTP, simple mail transmission protocol. Okay, for sending a mail, you are sending a mail, that is a SMTP. So SMTP server will respond to, if you are sending a mail, SMTP mail service or mail server will respond to your mail communication. And you are want to receive a mail, then you use POP3 or IMAP, okay, to receive a mail. So when you send a request with a POP3 or IMAP, so the server, incoming mail server, understand you want to receive a mail or retrieve a mail from the mailbox. TFTP, trivial file transfer protocol, this is also for transferring files, but that is a remote configuration files or a upload or download a configuration file, backup the configuration files of a remote devices like a router, servers, and stuff. DHCP server, DHCP dynamic host configuration protocol, so which assign DHCP server assign an IP address to clients automatically. DNS server will give an IP address of a particular domain or a host in the domain to the clients. It means, guys, that statement is a little confusion, but I'm frankly telling, directly I'm telling, if you open a website, this is a Java T pointer website I've opened, but I don't know this website IP address, this website related server IP address I don't know. How I got this? How can I able to communicate without knowing a IP address? The DNS server will give IP address of www.java.t point. You can tell in a with the example also, okay, for easy to explanation, guys. Okay, what is a DNS server? So when I open facebook.com, www.facebook.com, when I open www.facebook.com, okay, but I don't know the IP address of facebook.com. So my system send a request to the DNS server. So DNS server returns the IP address of www.facebook.com. So I can able to communicate to DNS server with the IP address. Okay, and all communications by IP address only. So you cannot communicate with a name or a MAC address. All communications by IP address only. So like that you have to tell an answer. Even for a DHCP, guys, dynamic host configuration protocol. Okay, so you want to connect to the network, you need an IP address. Okay, so how to get an IP address? So IP address can be configured manually or automatically. So DHCP server, when you connect in the network, when you connected to the network, in the network, if you have a DHCP server, the DHCP server assign IP address to the machine automatically. Not only to the computers, also nowadays we are using a lot of devices, mobile phones, tablets, computers, laptops, different, including smart TVs, smart printers. Okay, we need an IP address to connect in the network. So we are using DHCP server to assign an IP address. And where is your DHCP server? Your router is act like a DHCP server. Your Wi-Fi router act like a DHCP server. So NTP server, so network time protocol, it is synchronize the time as per the client's time zone. Kerberos and LDAP both are authentication protocol. SNMP is a simple network management protocol used at a monitoring time. So these are the things we discussed in the last class. Okay, I hope you got the point. So if in case if I don't get a time, then I want to skip this topic, this protocols kind of stuff. Guys, are you okay up to now?
Yes, sir.
Yes, sir. Sir, what is DDNS?
DDNS. DDNS usually for attacking. Dynamic DNS. PDOS, method of automatically updating names around domain name, define real time with the DDNS of its configure host address. I don't know what is this. Okay, so that's what I'm reading. It is here. It is saying what it is in animated series. You can go and try. You can configure DDNS in our PC means usually earlier we have a cache DNS and this is a automatic DNS. It update your records automatically. Something it is saying like that. Yeah, this diagram already I told this one. Actually, there is a actually as you know, so a cache DNS server is there. Maybe it is a certain replacement of cache DNS. So it is like number of queries are creating in the internet because DNS is actually not a single point. It is huge hierarchical structure is there for a DNS. Okay, huge hierarchical structure is there. Column is okay. Um, this entire hierarchical structure. So I'm not going, but instead of searching in total hierarchy, the cache DNS server generally stores once queries happen, it stores. For example, google.com. Out of 1,000, so 1,000 members are using, means almost all 99.99% people are using a Google related services. So there's many queries are happen. So what happened? So in ISP, what they will do, they'll maintain a one cache DNS server. So whenever the repeated queries are there, they store in this cache DNS server for a certain period of time. Okay, I think that is the one. There's a dynamic one, and of course DDNS. One more dynamic is there. That is by automatically domain joining related part.
Sir,
Okay, leave it. Yeah, tell me.
actually, I was learning yesterday about the DNS, so I got the name DDNS. So it's said that DDNS is a dynamic DNS, which is the method updating in real time on a domain name system. So there is a two terms, that is a forward and reverse lookup. So for that thing, I was
Okay.
asked that forward and reverse lookup is for which part, DNS or DDNS? Which is the question for my side.
DNS only. There is no concept of the DDNS. DDNS that is additionally came up. So that is automatically adding the records. Okay, so
Okay.
when you are creating new domain, so automatically it search and add that into the database kind of stuff. But this what is the forward and reverse lookup? That is in DNS servers. Actually, DNS is a server, right? So in DNS server, we have a forward lookup zone and a reverse lookup zone. Forward lookup zone, how it is, the zones are there. For example, I have my zone name like a latif.com. I created a one domain name called a latif.com. Okay. In my domain name, I have a multiple servers are there. For example, my server name is server A. Okay. Or another server name is web1. Another server name is mail1. Okay. So, and this server having an IP address, and this server having an IP address, this server having an IP address. Name to IP address. Now server A name is server A dot latif.com. This is called a FQDN. FQDN. Fully qualified domain name. Same. Web1 dot latif.com. It is also FQDN. So instead of one, like you are seeing, look at this guys, docs.google.com. But this is not one, no? So this is why this is not opening. Okay, look at this. This is www.google.com. This is docs.google.com. I want to open a mail. This is Meet. Okay, this is meet.google.com. Mail is different. So mail is mail.google.com. So what is the difference? So those are a different servers, and every server having their own IP address. Okay, so this complete name we call it as a FQDN, fully qualified domain name. Means this is the domain name, and this is the host name or a server name. Host name, generally we have to call it as a host. Host means it can be any device. It can be a normal computer also. Next, in reverse lookup zone, it is pointing based on the network. So it is pointing based on your network part is there. And in IP address, there is a network part and host part like this. So for example, so this is some IP address 1, 2, 3. So this IP address 1 is belongs to server a.latif.com. IP address 2 is belongs to web1.latif.com. Okay. So this is reverse lookup zone. Reverse lookup zone means IP address FQDN. Forward lookup zone means the host and an IP address. Okay. Domain in the host. This is DNS. So when I add a new record, so automatically record will be added as per their domain and IP address. It will be added. That is a dynamic DNS. That is a different concept because people are doing so many additions. So just it's a method only. It is automatic method. There is a no separate DNS concept. It is so just a method in a DNS. It is dynamically updated DNS records without need of human interface. It means you no need to go and add a DNS names here. Okay, you need to go to DNS server and add a DNS names there. It is automatically adds. Useful updating A and 4A records. A means IPv4 IP address. 4A means IPv6 IP address. Okay. So we can manually add a name and IP address in DNS servers. DDNS server, nothing. It is a method in the same DNS server. So which is add name and IP address automatically. I have a DHCP server. So when client got an IP address, automatically it will update information. In a router configuration also, there is a DNS binding is there. That's a binding only. Okay. It is not DNS class. That's why I'm not going that one. So I'm suddenly disconnected. Guys, are you able to see my screen now?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. Suddenly I'm disconnected. I don't know. Okay, guys, we have to finish this part and we have to finish another parts also. But I want to revise once. That's why I showed everything. Okay, so one by one we'll see. Application layer. So actually, whether I will tell this one or not, I may miss. So without worrying, that's so important things I covered already. All 7 layers, names and protocols, port numbers, and OSI layer and TCP/IP comparison. We are covered already, but now we have a time today, so we'll go into discuss about one by one. Little faster because I already have taken your time. Today is 17/12/2022. So we'll discuss remaining part. Okay, so here it is. Guys, application layer. Application layer is about applications only, not a separate thing. Application. Your web browser is an application. Your mail server utilize certain applications like a Tomcat application, HTTP, Apache, HTTPD, or built-in roles like a Microsoft Internet Information Service, IIS, Glassfish. These are all server side applications. Okay, the application level in the both client and server side application level. Next one is protocols level. Meaning is, for example, in command prompt, I can put a ping www.google.com, but I cannot put a HTTP command here because ping is a command. Ping is used ICMP protocol, but HTTP it's a direct protocol, of course. But which application, what type of protocol it is? Okay, for example, I use a FileZilla. So FileZilla is an application used for a FTP purpose. I can use this application to upload or download files from FTP for connecting FTP. Okay. Putty is an application used to connect a remote server using a SSH or a Telnet protocols. Okay. Like that, each and every application has certain things to deal with a certain kind of protocols only. Application layer dealing with a server side and client side application. Best example for application layer is your web browser only. Web browser for a web access purpose, Outlook for a mail communication purpose. It is a mail client application. Putty is a remote access purpose. Okay, so for accessing remote machine using SSH or Telnet protocols. Okay, so SSH and Telnet for that we use Putty kind of stuff also possible. FileZilla, cuteFTP, these are the client application. So for a FTP protocol, we use FTP type of protocol. mstsc, a Microsoft Terminal Server Connection. mstsc, Microsoft Terminal Connections. SC, not TCS, mstsc. TSC, so TSC. Computer See this? You want to connect a remote machine using a remote desktop connection. So this is the application. Okay, like okay, application, client side applications and server side applications and the protocols with the application layer. That is the application layer. So presentation layer again. So what are the data while you are sending a data or receiving a data? Either a server is sending a data or client is sending a data from either. So usually like first of all sending the server or client side. While you are sending a data, you have to encode the data. When you are receiving, of course it is, you have to decode the data. So we have to convert the data. What are the data format, original data format it is. Okay, what are the protocol, what are the type of communication it is. Okay, so what are the data is, we have to convert the data into ASCII format, that is a encoding. Okay, so next one is you have to compress the data, so then data size will be reduced, right? So yeah, compress the data. Encrypt the data. For example, you are using HTTPS or SSH. Data is encrypted, right? So you are using encrypted protocol types. Encryption is there. Then data should be encrypted. So presentation layer, what to do? Encoding, decoding, compress, decompress, encryption and de-encryption. Very simple one. Next one is session layer, guys. Session layer only one line, but it is very important. If you need what session layer will do, lot of big stories also there. But I will tell only one story, so we'll try this. Session layer will create a session, maintain a session, and terminate the session. Guys, when you are sending a data, like you are sending a request, or you are sending some data, or you are sending a request. So whatsoever it is, source and destination. So when you are sending, so while you are sending, first of all, a session ID will be created. You're sending a request, you want some file, for example. Okay, you open a web page. So you're trying to ask, I want a web page data. So you are sending a request. So a session will be created. From your side, session is created, session has a session ID. Okay, with that session ID only you are sending request. And this server will understand what is your request by protocols, of course, and it is also save the session ID in this side, and it returns what are the data you required, what are the information you required. So based on your request, it gives some response with this same session ID. Okay, so once the client, once the piece A, B, we think like this. A completely received data. Okay, A send a request, B received it, B given back, respond to the A completely received or completely downloaded data. Think like that, it is downloaded, completed. Then session will be terminated automatically. Till the time session will be maintained. I'll give you best example, guys, because you know everybody knows session layer. Everybody knows session layer. You don't need to be a computer literate also. Okay, you don't require to know how network works, but everybody knows session layer. How? When you do payment, you know, you go to IRCTC website or maybe Amazon, Flipkart. You go to payment session, right? Payment session. So when you are giving all the details, click OK. Some round it is going on, no? And it will tell do not refresh. Do not refresh or press the back button. Why? We are getting like this. So we are getting right. Do not do not refresh or press the back button. Why we are getting like this? While payment is going on, with your session ID only, payment will be completed with all the payment related. So request sent to the bank will approve your payment, and once approved the payment will go to your Amazon. Amazon will tell confirm the order. Payment is successful. Order will be confirmed, right? So if in case you refresh, meanwhile you refresh, so what happen? Payment will be no one knows. So bank is approved, but meanwhile you are refreshed. So your Amazon don't receive the payment from bank. The session is disturbed. It is you create a new session. Understand, guys, why it is showing? Do not refresh or press the back button. No one is responding. Why I'm teaching also, I don't know.
Got it, sir.
Okay, guys, the up to first three layers are simple because of application layer dealing with the application, client side applications. Okay, client applications, server applications we are dealing. Okay, next
Yes, sir.
next layer is presentation. Yeah, tell me.
I am saying yes, sir. We got it.
Okay, good. Presentation layer is encoding data, decoding data. Next one is encryption, decryption, compression, decompression. Encryption, decryption, compression, decompression. That is presentation layer. Session layer. So when you are sending itself, it is a session layer will be create a one session ID. So you have to send and receive. The complete transaction must be in the session within the set session only. So any network disturbance occurs, any network or internet disturbance occurs, the session layer will be gone. The session ID will be expires. Okay. So for example, you are downloading a data, 100 MB data is there, 100 MB only. Nowadays, 100 MB maximum less than a minute you are downloading. Not even a 5-10 minutes also. 100 MB less than a minute you are downloading. In a olden days, 100 MB it take almost like a 100 minutes also. Time is also there. That much of slow net. Nowadays we are getting very fast broadband connection, including 4G type of mobile network. Also 100 MB is very easy to download. Point is not that one, guys. Point is while you are downloading a data. So once it is downloaded in your PC, that is the good one. Okay, so 100% downloaded, good. For example, you are 90% downloaded, 90%, 99% downloaded. Now your internet is got disturbed. So that 1%, that 1 MB is not downloaded. So you are an incomplete download. Now internet is back. It cannot continue because meantime the session ID is disturbed. So session is terminated automatically, so you have to re-establish the session. That's why we are using for downloads, heavy downloads mainly, free download manager or a IDM. So internet download managers, torrents are better for downloading heavy data purpose. Okay, so normal 100 MB, 5 MB, 10 MB, normal browser also supporting because faster download is possible. But you are downloading 1 GB, 2 GB, 3 GB type of data. So better to use free download manager or a internet download managers, IDM or a FDM kind of applications. Because even if your internet is disturbed, so we can still able to download after internet is back. Okay, because it saves the session ID. It can able to re-establish the session. Yeah.
Sir, error detection or error corrections both are in transport layer.
No. Error detection, data link layer. Error correction, transport layer.
Data link.
So
Okay.
you are reading this one. Very good. Very good. Okay, guys. Next layer is a transport layer. Transport layer provide a end-to-end connectivity. Your transport layer is chop the data. What are the data from? What are the data? You are in the application layer, presentation layer, session layer. The data in the each layer we call it as a PDU, packet data unit. Okay, and application layer data is data only. That is called as a data only. And presentation layer, what are the data is, either it is encrypted or encoding or compressed, but it is a data only. The session layer data is also a data only. But that data, what are the data it is, we called as a PDU, packet data unit. It is the packet data unit is chopped into small pieces. Small pieces. Okay, that is called as segmenting. The process we call it as a segmenting. Each segment is labeled with a numbering and sequencing order number. Okay, there is a sequence order number. So why it is a error correction is here. So I will tell guys, whenever a source send a packet to destination, if in case destination received a packet, destination will send an acknowledgement. Okay, for example, missing bits will happen here. So sequencing and that part, I'll give you a small example. I'm sending a message, hello, how are you? Okay, so what I've done, I cut these pieces like this and I am numbering it. Just for example, our understanding, guys. I send a packet to destination. Destination received a 1/4. So destination give an acknowledgement. Yeah, I received one. Again, destination, we have sent a second packet. Yes, I received second one. And I sent third. And I sent 4. Okay. And I received a acknowledgement for 4 only. Okay. I didn't receive anything for a third. So at destination, what is the packet things? Hello, how you received. Just for our understanding, guys, really it won't happen like this. Okay, hello, how you, and this 3/4 is missing. And now the source understand because of this no acknowledgement. Okay, no acknowledgement. Then 3 send again, and the third packet is send again, and source received a acknowledgement 3. Now R is received. This is 1, this is 2, this is 4, this is 3. So this is not assembled properly, right? So because of this sequencing and numbering, it orders again. Like a hello.
Yes, sir.
Yes, sir.
Yeah. Okay. So here it is. It is ordered. So this is called a error correction. So whenever the destination is not received, we'll send the packet back and we'll put it into the order properly. So that is called a error correction. So error correction occurs at transport layer. And also transport layer do multiplexing and demultiplexing of TCP and UDP protocol. Guess lot of people are confused with the TCP and UDP approach. So what is the confusion? I will tell that confusion part. Okay. TCP UDP part, guys. No one is confusing, but still there is a lot of mistakes people will do at a TCP UDP kind of stuff. presentation layer. Okay, so this TCP UDP I will tell. Guys, we know the protocols. That's why already I told protocols. Okay, so we have seen the protocols. HTTP, HTTPS, FTP, SSH, Telnet, RDP, SMTP, POP3, TFTP, DHCP, DNS. Not only these protocol, guys, there is several protocols are there. These protocols, some of the protocols are TCP type protocol, some protocols are a UDP type protocols. Okay, nothing it is. Okay, very simple. There is a certain protocols are a TCP type protocol, some protocols are a UDP type protocols. For example, DHCP, TCP, UDP type protocol, TFTP, UDP type protocol, DNS, UDP type protocol, HTTP, SMTP, FTP, SNMP, like this. Some protocols are TCP type protocol. Okay, guys. Some protocols are both. Some are TCP and as well as UDP. If you want a list of TCP UDP protocol list, so you can find out like a protocols port numbers list. Like this. Okay, you can see it is a DNS, it is a TCP and UDP, DHCP, UDP, TFTP, UDP, HTTP, TCP. Okay, so protocols are either UDP or TCP or both. Okay, so TCP type protocols are acknowledgement based protocols. TCP type protocols are acknowledgement based protocol. What is this acknowledgement based protocols? Whenever you send a data, whenever you send a packet to the destination received a packet. Whenever you send a packet to the destination, okay, once destination received a packet, it will forward it will give acknowledgement for that packet. So source send a packet, destination received, and destination send an acknowledgement. Like a source send a packet, destination received, destination send an acknowledgement to the source. Okay, so source understand destination is received. So what is the meaning of this check marks? Where is mine? What is the meaning of these check marks?
That user
This
read
is 12, right?
message.
Very good. Message sent successful, message received, and message checked, right? Very good. So same type communication. So source knows destination received packet. No errors, no problem. So based on the acknowledgement, like a delivery report. Okay, like a delivery report. Source send a package to destination, destination give acknowledgement to the source, that is I received a packet type. So whenever source does not receive acknowledgement from destination, okay, for certain packet, so source does not receive acknowledgement. So what happened to the from destination? Source think destination not received a packet. Source think destination not received a packet. What source will do? It will try to send the packet again. Send the packet again. So like that TCP works. That's why it is a TCP is a reliable. TCP is a reliable protocols. TCP protocols are reliable protocols. So the TCP type protocols are acknowledgement based, reliable, connection oriented. Guys, again, here some confusion, not confusion exactly, say a misguideline is there. Most of the time, guys, from our certain people will give misguidelines, means wrong information. Okay, so because they're having their own interpretation of things are there, so that's why they give that column. But connection oriented, so TCP is a connection oriented. Guys, connection oriented, connectionless is not belongs to wired or a wireless. Okay, it is not, it is no point of no connection between connection oriented and connectionless related. Okay, connection oriented means source knows destination is receiving a packet by destination sending an acknowledgement to the source. Okay, that is a connection oriented. For example, in a people are telling someone is telling a story to you, you are listening. So how other person knows you are listening? You are giving some response, right? So how hello, okay, so based on that you give some response or some voice you are giving, so other person understand, yes, you are understanding what he is telling. This is connection oriented. Okay, so two-way type of communication. So wired or wireless? No. Okay, it is not that point. Okay, connection oriented means source knows destination is received because of destination is giving acknowledgement for each and every packet it receives. Next, UDP type protocols are connectionless, non-reliable, no acknowledgement based. So UDP type protocols does not receive acknowledgement from the destination. So source does not know whether destination received a packet. Source send a packet, destination received. Source send a packet, destination not received. So, but source don't know destination is received or not. Okay, that's why it is a connectionless protocol, non-reliable protocol. Someone will add a one more point, guys. Some people add a one more point here. So TCP is slower than a UDP, or UDP is faster than TCP. Of course, both statements are same, and of course that is also good statement only. But I'm not written that one here. But because of slow and faster is a different kind of stuff. Why UDP is a faster? I will tell, that's it. Because in TCP there is an acknowledgement base. Source send a packet, destination received, and destination has to send acknowledgement. So then source understand destination is received, right? So source has to wait for a packet or for a certain packets. Source has to wait to receive a acknowledgement from this destination. But in this UDP, source does not wait anything. It will keep sending a packet. So there is no delay for sending further packets by UDP. So it is faster. Okay. So that is the point, guys, here. Again, what is a transport layer? Transport layer cut the data into small points, small pieces. That is called segmenting. Okay, segmenting, each segment in English called segment. Each piece data is having a numbering and sequencing order for error correction purpose. Whenever destination received a packet, the destination will, whenever destination received a packet, so destination will give acknowledgement to the source. The source understand destination is received a packet. If in case destination not received a packet or a source some destination, so that there's some packet issue is there, source is sending a packets again, it will able to send a packet again, or maybe While it is source sender packets, destination collect the packets and assemble the packets in a proper order by using numbering and sequence. That is called error correction at destination by transport layer. Guys, multiplexing and demultiplexing of a TCP UDP. So TCP type protocols we are using, UDP type protocols we are using. All TCP type protocols, they put it in a TCP box. Very simple to say. All UDP type protocols we are using, they put in the UDP box. Okay. So in a packet only, it is in a packet inside the TCP and UDP session is there. All TCP protocols in TCP, all UDP in a all UDP session only. There is a flow control. Flow control means, so guys, if you have a source is 100 Mbps, destination is 10 Mbps. For example, just for example. So you can able to send high-speed data packets, right? But destination cannot able to receive it. So you have to estimate how much destination can able to receive a packet at a time, at this time and at a time. At this particular time, how much destination can able to receive a packet. How many packets at a time it can able to receive at this time, how many packets it can able to receive at a time. So that is called a flow control. So all this segmenting data, the segmenting data is numbering, sequencing, TCP, UDP information, all combined, they will put it into a TCP header. This header will add it to our packet data unit, which is data from session layer. Okay, data from session layer is added to TCP header. The TCP header contains TCP, UDP protocol informations, okay, numbering, sequencing, segmenting information also. The whole data, the whole packet data unit, we call it as a segment. This segment we are sending to network layer. Don't worry guys, only the transport layer is bigger.
Hello, sir. Please, hello.
Yeah, tell me.
Sir, please describe a multiplex and demultiplexing briefly, sir.
No. So already to TCP, UDP type protocols, right? So while you are communicating, you may use one or a multiple protocols. If you are using some TCP protocols, they will put it into TCP multiplexing. Means instead of one by one protocol separately spreading, they put a one header, that is a TCP. Under TCP, what are the protocols we are using? For example, you are using HTTP. Okay, and if you are using UDP parallelly, like for example, you are using DNS, then under UDP box, multiplexing, 1 second, TCP IP, all OSI, transport layer.
Sir, can I say that like multiplexing has a different input with one output?
It is like this,
And demultiplexing can like single input and multiple.
What is multiplexing and what is demultiplexing?
Yes, sir.
Multiplexing means it is like a different values. Different 1, 2, 3, 4, 5. You put everything into one single box. Multiplexing.
Yes,
now
sir.
you are transmitted. This is again divided into separate values. Multiplexing and demultiplexing. Not all TCP protocols and all UDP protocols they put it into under TCP and UDP like this. Means one enclosure. Very simple, I will tell. Imagine you order something, all small items, they put it in one single box. Multiplexing. You received that package, you open the package and you will separate everything. That is called a demultiplexing. Okay.
Yes, sir.
Okay, that's a simple multiplexing. And the TCP type protocols we are using, UDP type protocols we are using in the communication. So what the packet, what is total packet will do? So all TCP parts into one TCP box, one UDP box kind of stuff for our understanding. Okay, so this is about a transport layer, guys. Transport layer, finally, it generates a segment. So our data from session layer is added with a TCP header. So the total packet data in it, the total layer data is segment. This segment is sent to the network layer. In the network layer, there is a two parts are there in a network layer. That is, in the network layer, okay, there is a routed protocols and routing protocols. In network layer, we have a routed protocols and a routing protocol. Routed protocols and routing protocols are there. What is routed protocols? Routed protocols are IP address, IPX, SPX, so much of story is there. But I am telling routed protocol means IP addresses, logical addressing. Routing protocols are how to reach the destination. Routing protocols will tell how to reach the destination, okay, how to forward the packet to the destination. So routing protocols tells how to reach destination, path to reach destination by routing protocols. Routed protocols are nothing but a logical addresses, which is our IP addresses. Dealing with the logical addressing, which is our IP addresses, IPv4, IPv6, like that. Guys, so we got a segment from transport layer, and there is a network header will be added to this segment. So total packet, we call it as a packet. The packet is actually from network layer only, not from anywhere. It is from network layer only. Okay, it is a packet. Okay, what is this network header? It adds a source IP address, destination IP address, and routing information in this network header added to your segment, that is called a packet. This packet is forwarded to data link layer. What is the data link layer? Yeah, tell me.
Sir, actually, kindly elaborate the major difference between Internet Protocol version 4 and version 6. And if IPv6 is more suitable, why IPv4 is there?
Yeah, we'll discuss that in IP addresses. Generally talk, IPv4 is we are all worldwide spreaded protocol is IPv4 only. We are all communicating through IPv4 only. But IPv4 has a limitation because the total IPv4 IP addresses are 4.3 billion IP addresses only. Earlier it is very high, now it is very less because the world population, worldwide devices increased. One person having multiple devices. Lot of management manipulations. Public IP addresses are very limited. That too, IPv4 is divided into 5 classes. Out of 5, 2 classes we are not using. Only 3 classes. Out of that one, there is certain IP addresses we don't use it. Okay, so practically say it is not a 4.3 billion IP addresses. Practically it is 3 billion, less than 3 billion IP addresses only. But whereas IPv6 is a 128 bit. Okay, IPv4 is 32 bit. So IPv4 is 128 bit. It is a 3.4 into 10 to the power of 38. Means 34. After 34, put a 37 zeros. 3.4 into 10 to the power of 38 means put a 34. After 34, put a 37 zeros. 37 zeros. Tell me how many crores, how many billions, how many crores. Okay, billion wise or crores wise, a trillion wise. Okay, so you have to tell. So it's a billions of IP addresses we are getting with IPv6, but IPv6 the length is very bigger because 128-bit process is important. Processing of 128-bit is very important in a binary. It represented in hexadecimal. It represented in hexadecimal. And of course, certain countries, the entire countrywide and certain organization like a Zio Airtel kind of organization, for their internal communication, they are using IPv6. But globally, still we are using IPv4. Okay, but in a local means in a one kind of segment in a country or in a certain places, we are using IPv6. Of course, Google, Facebook, everybody is using both IPv4 and IPv6 also. Maybe in future IPv4 completely closed, but still we are using IPv4 as a global communication, main communication. IPv6 is upcoming. IPv6 is a very bigger than IPv4. Okay, some people say secure. I don't know the security features in both the ways. So how it is secure? Again, the learning and IPv6 is required a lot of information about ISP related information added, as region wise information will also be added. Okay. What is your question? That is enough, or you want more?
Yes, sir. Yes, sir. No.
Okay.
I got that.
So IPv4 32 bit, IPv6 128 bit. IPv6 is very bigger. Guys, data link layer. Data link layer having 2 layers, sub layers are there. One is LLC and one is a MAC layer. LLC is a logical link control. Actually, this LLC dealing with the WAN protocols. When you are connecting your devices to WAN kind of communication, you want a WAN kind of communication means you have to use WAN protocols. PPP, SDLC, frame relay, MPLS, these are all WAN protocols to connect in the WAN. Guys, we are getting internet. So I will tell one internet, that is PPP type or a PPP OE type internet connectivity. For example, you are using U broadband, Gazan, or some ACT type of broadbands are in the ACT. They use PPP OE. Means they have a one junction box from ISP to the customer. So they use some intermediate box system is there, PPP OE box system. We are getting connection from PPP OE type. That's why we are getting normal LAN cable kind of stuff. Okay, so PPP OE. But if you are using a direct point-to-point protocol kind of stuff, like router is connecting directly ISP, that is point-to-point protocol, they use it. Of course, different technologies are there for connecting in WAN communication. SDLC, Cisco proprietary one, frame relay, MPLS, these are all protocols are used for WAN connectivity. It is LLC layer. In another layer is a MAC layer, that is called a media access layer. You know already it is a 48-bit or a 12 hexadecimal 12 hexadecimal numbers are there. It is also called as a physical layer. Sorry, it is also called as a physical address. So MAC layer is about a MAC address. So physical address, it is 48-bit, 12 hexa numbers are there. Okay, so data header is added to packet. The packet is added to data tail. The data header is source MAC address, destination MAC address, the packet plus CRC. Okay, packet plus CRC. CRC, cyclic redundancy check, error checking purpose. Okay, source MAC address, destination MAC address is as a data header, which is added to packet. The packet is as a data tail, CRC is added there. Cyclic redundancy check, guys. CRC is an algorithm. CRC is an algorithm. Cyclic redundancy check algorithm. What is the use of CRC? For error checking. Okay, CRC is not a completely new for you guys. You know already CRC. You know if you have a WinRAR files, Windows not rar dot WinRAR files are there, no
Yes, sir.
dot rar files. If you open, you can see there is a CRC value, CRC 32 value, 32. What it is? CRC is an algorithm. It creates certain value from your data only by certain calculation. We are use this CRC for error checking and repairing purpose also there. So where is error checking? Data link layer. Where is error correction? Transport layer. Okay. So this total PDU is called a frame. This total PDU we call it as a frame. This frame is sent to physical layer. Okay. So physical layer is the last one. If you understand OSI layer, okay, layer by layer, the troubleshooting of network is very easy. You can troubleshoot by understanding which layer it is, kind of stuff also. Physical connectivity issue like that we can able to understand. It's a physical layer. The physical layer converts your data into bit stream. Physical layer convert your data into bit stream. What is the bit stream? Zeros, ones kind of stuff. Okay, that is converted into your electrical signal or radio signal or light wave signal, depends upon the what media you are using. You are using a TCP or sorry UTP, STP type of connectivity, Ethernet type of connectivity, electrical signal, coaxial wire, electrical signal, based on that coaxial wire signal only. Okay, so if you are using a fiber channel, light wave signal. If you are using Wi-Fi kind of stuff, it is a radio signal. Different signals are there, 2.4 or 2.5 or 5 gigahertz frequency. It's a carrier signal. It is right. So it's a physical layer. So these are the total your OSI layer kind of stuff. So again, here two ways. Already I told sending and receiving. So it is quite easy if you are do this one for your learning purpose. Okay, guys. Source PC is there. That is called a PCA. Source PCA. Destination is PCB. I am sending a packet. So for example, I am doing some ping command. Ping use ICMP protocol. Ping use ICMP protocol. Where you do ping in command prompt. So like that, guys, it is application layer related one. Presentation layer So what happened? The application layer, your command prompt, your ICMP protocol, and your command is ping. You given a destination IP for pinging, right? You want to ping someone, you want to ping the destination IP address you have to give, right? So now you given this application layer. So what is this ping command? Will send certain packet, like a echo packets it will send. The presentation layer will encode the data. Presentation layer encode the data. Presentation layer compress the data. Presentation layer, if in case any encryption is there, it will do encrypt the data. And session layer, the data will send. Now finally that PDU will send to the session layer. The session layer will add the session. This is the my session kind of stuff. It create a new session ID, will add it to the data. Now the transport layer segment the data. The transport layer do chop the data, that is called segmenting, sequencing, numbering. Okay, and what protocol we are using, is it a TCP type or UDP type? What is the capacity of a destination PC, like that windowing? Okay, so that information is added to your transport layer, transport layer. So then segment is created, okay, to your data. The segment is sent to the network layer. Okay, segment is sent to the network layer. Network layer knows what is the source IP address. What is my source IP, guys? Here, while you are sending PCA at PCA, source IP. What is source IP? Source IP is a ASCII IP. Here, what is my destination IP address? IP address. Okay, so at PCA, your source IP and destination IP will add it to your segment. Then it will become packet. This packet is added to this packet is forward to data link layer. At data link layer, what happened? The source MAC address, which is yes MAC address, and destination MAC address means actually it should be B's MAC address. Okay, B's MAC address. Sometimes for first time communication, use MAC broadcast address. That means there is a 12 F's are there. Okay, 12 F's are there. 12 F's, not FFs. 12 F's means F like that. I'll show you the destination because we don't know. We know the destination IP address, but because you are communicating with IP address, you know the destination IP address, but you don't know the destination MAC address. You didn't ask a destination MAC address, right? Like that. So 12 F's like FF, 6 F's completed, FF. I think 12 F's completed. Like this.
Yes, sir.
Okay, this is a 12 F's. This is the MAC broadcast. Either if you know the destination MAC address, it will automatically add. If you don't know the destination MAC address, use the MAC broadcaster. This bottom story I am writing separately. It means parallelly I am writing, but try to understand the bottom story also, because I am going to tell one more command there. That's why. Okay. So destination at data link layer, source MAC address, destination MAC address. If you know, then we will add it. Otherwise, we'll use MAC broadcasting address plus CRC value will be added to your packet. So that is called a frame. That is called a frame. This frame is sent to the physical layer. Okay, this frame is sent to a physical layer. This frame is sent to a physical layer. Physical layer convert into bit stream. The bit stream is either a what kind of signal? For example, I am using TCP UDP. I am using twisted pair cable. So electrical signal. Again, at destination, another computer destination. At destination, what happened? So signal is received at physical layer, right? Through our Ethernet, we received a signal like a at destination physical layer received a electrical signal. Electrical signal is converted into bit stream. The bit stream is converted into frame. This frame is forward to data link layer at BPC. At PCB. So data link layer received the frame and check source MAC address, destination MAC address, okay, and verify the destination MAC address. Is it a MAC address is belongs to me or not, like that. Next, it will check the data. Error checking, right? We using CRC, it check the data is safe or corrupted. While you are transmitting data through network, mean through wires or wireless, data may corrupted. So what happened? At destination, I will check with CRC data is good or corrupted. So error checking. If everything is good, then we got our packet from data link layer. This packet is sent to the network layer. Guys, a small point I have to add here. At PCB. At PCB, now we are PCB received, right? So can you see this is the source MAC address? What is the source MAC address? Yes, MAC address. So I received a packet that contains yes MAC address, right? That contains yes MAC address. So I kept this yes MAC address aside. Like I received a yes MAC address aside. Now packet is extracted, packet sent to network layer. Network layer will check it, source IP address and destination IP. First of all, destination IP address is same as a base IP address. Yes, then it will accept the packet, complete accept the packet. Okay, data link layer may have a little confusion because of it received a packet, either it is base MAC address or it is a broadcast address. But it should not be different MAC address. Okay, so either it is its own base MAC address or it can be a broadcast address. But destination IP address must be base IP address. This is must be IP address compulsory matches. Otherwise, it will drop the packet. Okay. So again, guys, so network layer check the source IP address and destination IP. So it verify the destination IP and save the source IP. What is my source IP? Yes, IP address is my source IP address. Means based on my receiving packet. Okay, yes IP. And I received a segment. This segment is go to transport layer. Transport layer put order. This is the part of already existing packets. It is a part of that packet, or it will has to receive some packets and prepare for sending an acknowledgement, TCP type packet or UDP type packet. What type of protocols are there? What protocols, the sequence number, everything. Transport layer will do that one. So your complete packet collection at transport layer. All packets will be collected. All the parts of packets will be collected at transport layer. So that's why it is called a end-to-end connectivity. Okay. All packets are collected at transport layer. They order into the sequencing order. Okay. And make sure that protocols, port numbers, everything will be extracted here. Then packets will give it to the session layer. Session layer save the session ID from PCA. What are the session ID? To save the session ID and send to the presentation layer. Presentation layer decrypt the data. Okay, encrypted data will be decrypted, compressed data will be decompressed, and encoded data is decoded. Now the decoded data finally received to application layer at PCB. Application layer will verify what protocol, what type of request it is. So based on that, the application understand what is the kind of response I have to send. Okay, what kind of response or what kind of information it has to send. So it will be do that one. Okay. So that is the finally PCA to PCB we received. PCB received at application layer. Now application PCB is giving a response. Application layer understand a PCA request and try to give a reply. Okay, then application layer prepare a data packets and send it to the presentation layer. Again, encoding, compression, encryption, session ID added, and transport layer. Again, segmenting, numbering, sequencing, windowing, TCP UDP, multiplexing. Then it go to network layer. Network layer, we already know from where packet is came. That is source IP, destination IP changes. Source IP, destination IP changes. Now source IP is a base IP. Okay, what is the source IP? Base IP. Destination IP, base IP. Source MAC address. So that will be that is become packet. The packet is sent to the data link layer. Data link layers source MAC address. So it knows its own source MAC address and destination MAC address. Destination MAC address will be added to your packet, and CRC, new CRC will be created. So that is become frame. This frame is sent to the physical layer. Physical layer convert the frame into bit stream to the signal like a electrical signal sent to PCA physical layer. Again physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Okay, so finally we received it. Guys, understand how packets are travel from application to physical, physical to application, application to physical, physical to application. Understand this part?
Yes, sir.
Okay. So guys, the small point I said I will tell. Right? So here it is. I got a destination MAC address, but at A to B, from A to B, from PCA to PCB. So we are sending for first time from A to B. Follow the sequence, okay? From A to B, we are sending a packet. That time we know the destination IP address. We know the destination IP address we are sending, but we don't know the destination MAC address. What we use a broadcast MAC address. Okay, so use a broadcast MAC address. But at receiving at PCB, what happened? PCB received a packet PCA APC, A's MAC address and A's IP address. Okay, it received maps A's MAC address. Sorry, receives A's IP address and B's MAC address, and it create ARP table. Okay, what is ARP This is also protocol. Address resolution. What is resolution protocol? Resolution protocol. It creates a ARP table. ARP means, what is that one? Actually, map IP address and MAC address. So whenever a system received a packet, whenever system received a packet, received whenever a system received a packet, it checks packets source IP and source MAC address and maps IP address and MAC address in ARP table. Okay, so what is the advantage of this one? What is the advantage? So it useful when it is useful when you are send packet to an IP address to a device. So easy to tell, difficult to write. So simple to tell, guys, very simple. This is APC, this is BPC. Okay, this is APC, this is BPC. I send a packet. So A received A's MAC address, right? And A's IP address also. So it maps like that. So when it is want to send a packet, so very simple, because of this table, when it is sending packet to A's PC with A IP address, but automatically A MAC address is also it will know. So you don't need to do broadcast MAC address. It can automatically add this A's MAC address here. So it is useful when you are sending packets to the devices, MAC bindings kind of stuff. Okay. So here it is from BPC to APC. How it will know the destination MAC address? So from B to A, source IP, destination IP, source MAC address, destination MAC address. Now is it not required, and MAC broadcast address. Why? Because ARP table. Okay, I will show you what is the ARP table here, guys. ARP-A. This is ARP table. How to check the ARP table? ARP space -A. and my network IP address is this one. You can see this is the IP address. This is the MAC address. This is how it is look like. This is IP address and MAC address. Like this. Just I want to put them in line. Okay. So we don't know which device, what the device. Guys, static means it is already fixed one, either manually entered or a fixed one. Dynamic means automatically it learns from it. I will show you one example with my mobile phone where it is in my pocket. My mobile is also connected to same network, same logical network. Okay, so I'm going to my Wi-Fi settings. But listen very carefully. Don't think I am wasting your time. Okay. So I am trying to check my Wi-Fi setting 1.33. Can you see 1.33 is not there now? Does not contain 1.33. Okay. Next one is my mobile IP address is 1.33 and my mobile MAC address is 9A8959 E7 5F69. Okay. Okay guys, that is my mobile phone MAC address. And my mobile phone IP address is last two digits are 1.33. Understand? My mobile phone IP address and this is MAC address. Okay. Now what I'm going to do is I'm pinging to my mobile because I cannot send a packet from my mobile, right? Ping is two-way communication 192.168.1.33. I'm pinging to my mobile IP address. I cannot ping with the MAC address. I am pinging to IP address of my mobile. So I send a packet and I will receive a packet because it's a pinging. So when I receiving packet from my mobile, so it will create this ARP table. So I send a packet and now I'm receiving a packet. Ping is successful. 1.33. This is my MAC address. Can you check 9A8959E75F69? See 695F E7598998. Okay. So initially this record is not there, but once the communication is happened, when you receive a packet, the system maps the MAC address and the IP address in the ARP table. Okay. So for example, you put only ARP, then you will understand these two things. Okay. There's several options also there. So you want to create your own ARP table, then you can try like this. Okay. In certain security purposes, in certain organization, in their security purpose, they will add this ARP static entries. So what is that meaning? If both IP address and MAC address matches, accept the packet, otherwise don't accept the packet. Okay. It can learn dynamically. It can learn dynamically or you can add statically. Okay. And also you can configure your system. If both MAC address, destination MAC address, destination IP address matches to your PC, accept the packet. Otherwise, don't accept. Okay. So these are the ARP address resolution protocol, maps IP address, and MAC address. Okay. So when you receive a packet, so what is the advantage, guys? When you are sending a packet, so you can send a packet with a proper MAC address and IP address next time. So this is about your OSI layer plus ARP table to and fro, and troubleshooting I didn't add now, so that's why not required. Okay, so I taken a lot of time.